Hello, myself Adarsh, and today I'm going to take a class on square and square roots. Okay, so this is a very nice and interesting and important chapter. By learning or by understanding the chapter very well, you can solve the various kind of calculations within a minute, and it is very crucial to learn this chapter by heartedly. Okay, so let us start. So when we talk about square and square roots, okay, and square. So first of all, in mathematics or any kind of scientific subjects, whenever you are studying, so it's very important that first we know the important principles and the applications of those chapters. So when we talk about the application part, so these square and square roots are used in almost each and every kind of calculations when you are finding the area. So let us talk about first applications. So in application part, if you are let's say if you are finding the area of square. So what is area of square? So area of square is nothing but your length into length, or breadth into breadth, or height into height. Actually, we all know that square is your two-dimensional figure, but yes, my point of view is that length into length is a kind of side, breadth into breadth is a kind of side, height into height is a kind of side. So you can say that side into side is nothing but your area of square. Okay, area of square. So here you can observe one pattern, that these two sides are same, these two length are same, these two breadth are same, and height is also same. So you can see that if let me take a number here. Okay, so if I choose 1, okay, so if I want to find the square of number 1, so what I'll do, I'll simply multiply 1 with itself only. Here I'll get 1. If someone asks you that, hey, can you give me the square of number 2, then your answer should be yes, because I told you that how you will going to find a square, by just multiplying the any kind of quantity whose square you have to find with itself. Like if you have to find the square of 2, you can simply multiply 2 with 2 itself, you will get 4. Similarly 3, which is equal to 3 into 3 itself, it is equal to 9. Then for 4, it is equal to 4 into 4, which is equal to 16. Similarly, let me take it up to 10, then 10 is equal to 10 into 10, which is equal to 100. Okay, so now you will observe a specific pattern between these numbers. Okay, I'll talk about square roots as well, but let me first talk about the squares. So the pattern which you will observe is that after finding out the square of almost up to 30 numbers, you will find that 1, 4, 9 and 6 and 0, these unit digits are repeating itself. So let me give you a little example about this. Suppose you have a number like this. Okay, 11. Now what is the square of 11? Yes, you are right. The square of 11 is 11 into 11, which is equal to 121. The square of 12 is 12 into 12, which is equal to 144. The square of 13 is 13 into 13, which is 169. So you can simply observe these results. I told you that we are getting almost similar results here. 1, 4, 9, 1, 4 and 9. Okay, the motive of telling this concept to you is that if you find some large number, like let's say it's a random number, you can check whether it is a perfect square or not. Now yes, what is perfect square? Perfect square means if the given number, if it is, let's say in a question, if a given number is 25 and someone asks you, uh, hey, can you tell me whether this 25 is perfect square or not? So how will you come to know that this is a perfect square or not? You can simply find whether it is a square of any natural number or not, whether I can write this number into the product of any natural number. So yes, I can write it like this: 5 into 5. So it is a squared number. So here the square of 5 is 5 into 5, it is 25. Okay, now in each and every square of the numbers in which whose unit digit is 5, you will find that there is 5 only. Their unit digit place is consisted with 5 only. So if you will see that yes, here is a, in your unit place there is a 5, that means this is a squared number. And how you represent this squared number? Simply by putting 2 in the power. Let's say here is a number which is x. Okay, x is a number and you have to represent it in the square form. So what you will do, simply put the bracket on x and give the power it as 2. It means square of x. So this is called as square of numbers. So in 7th standard you have studied about the Pythagoras theorem. The Pythagoras theorem, that what is Pythagoras theorem? That if you have a right angle triangle, let's say like this. Okay, so in right angle triangle, let's say it is a r hypotenuse. Okay, and this is your perpendicular. I am representing this perpendicular as p, and this is your base, that is b. So what is Pythagoras theorem? It is and let's represent the hypotenuse as h. That hypotenuse square is equal to perpendicular square plus base ka square. Okay, now if you see that here we are also using the concept of square numbers. So you can see that how important these squares are, and if we are able to understand the tricks, or we can or we can able to understand the basic patterns that how these square numbers are arranged, we can use these concepts to find the solution of the complex calculations. So that's why it is being an important topic to study. Okay, so let's discuss another pattern for this square numbers. Then we will discuss what are squares, which is also important topic. Square roots, we have discussed squares. Now we will discuss the square roots. But let's see if somehow if there is any other pattern which we can see. Okay, okay, let me tell you another thing. Okay, so here if you will observe, okay, let me first clear this part, then we will discuss. Okay, mm, Okay, okay, student. So now we will discuss about some other points on square numbers. So I was about to tell you that whenever you will get like at the unit place. Okay, let me write first. If on unit place of any that is more than or equal to two digit number, there is 0, 1, 4, 5, 6 and 9. Okay, then that number will be having the unit digit, then then here will be the square, then the square of that number will be having the unit digit same as that of the original number, as that of the original number. So here we have observed that pattern, that is, if any kind of number, let's say it's a 4-digit number and that 4-digit number is 1096. Okay, so this is 1096 and the unit digit is 6 है ना, unit digit is 6. So this unit digit is 6. Now that means what? That means the square root, or I will tell you what is square root. Just wait for a moment. The square root of this number will be having the unit digit which is 6 only. Okay, so the overall meaning of this whole statements and the concept, if I summarize it in one line, that if you get the value as 01469 in the unit place, then you can state that yes, the number, the original number have the unit digit which is equal to 6. Okay, so this is the trick which you can apply in finding the perfect squares. If any number which can be multiplied by itself, okay, multiplied by itself with the same number, then it is a square. Now if I have to find the square root, that means what? Inverse of that square number. You can state that square roots are nothing but it is the inverse of square. How? One thing also, we are what I have told you, that we are representing the square of any number, let's say x with power 2. So this is a squared number. You can say this is a squared number. Okay, now if someone asks you that tell me how you will represent the square root, so square root is like x raised to 1 by 2. Now it will be a little kind of complex, but it's not complex. Just simply understand the concept. I will tell you how this is true. This is the inverse of this number. Okay, the square number is x square, so this square root is nothing but the inverse of this squared number, which is x raised to 1 by 2. Okay, so how? Now if you equate the, now equate means what? That we are going to equalize these two numbers. So if you equate this number, like x raised to 1 by 2 is equal to x square, So you will find that if you are taking the square, taking the square of this number, okay, square of this number, this is a square root actually. So if you are taking the square of this number, square of what, let me write it again, x raised to 1 by 2 is equal to x square. Okay, so if you are taking square of this number, so what value you will get, x square is equal to x raised to 1 by 2 into 2, which will be cancel out, and you will get x is equal to x square, which is not right. It is not right. You will now you are in ambiguity that whether this is right or wrong. So this is right, not in the form of equation, but yes, in the form of original number and the squared number. Now this is your x. If you multiply it x by itself, x into x, which is equal to x square. So this is all about the squares and square roots, but I haven't give you the examples, illustrations on the square roots. So let us talk about the square roots first. Wait for a moment. Okay, let us talk about the square roots. So suppose if there is a number 4, if number 4 over here, if there is a number 4 over here, so if you find the square root of this number, how you will find the square root? You can write the square root if it is 2. You can find the prime factors of this 4. How you will get the prime factors? That let's say here it is 4. So if you find the LCM of if you will take the LCM of this 4, then 2 2s are 4 and 2 1s are 2. Here is 2 into 2. Okay, and if you find the square root of want to find the square root of 25, you can simply again take the prime factorization method, like 25 is here and 5 5s are 25, 5 1s are 5, then it is 5 into 5, which is a square root. So here you can see the two there are the pair 5, those two 5 are in pair. So if these two numbers are in pair, then you can simply write it as 2 only. In the second case, again here these two 5s are in pair, so you can simply write it as only 1 5. No need to write 2 5s. Okay, so this will be your square root of 4. This is the square root of 4, and this number is the square root of 5. Okay, so let us take few examples. If you have to find, let's say 36, this is a 36. Now you tell me that whether it is a perfect square or not. So you can tell it is a perfect square. How? Because you are able to see that in the unit place of 36 there is 6. So that means what? That means if there is a 6 in the unit place, that means it's a perfect square. But this is not always right. Why and how, I will tell you. Okay, so this is a perfect square. Now if you have to find the square root of this, take a LCM of this. Okay, you will get 6 into 6. Again it is a pair of 2, you have to write it only once. So 6, now 6 is the square root of this number. Okay, so here we have learned the what is square and how to find it, what is square root and how to find it. Now to find the square root of any number, there is a lot of concepts and lot of methods are there. Like you can simply, let's say 81 is a number, so this you can find the square root of this 81 by simply subtracting repeated subtraction. By doing the repeated subtraction, you can find the square root of 81, like 81 minus 1, it will be 80 minus next odd number, that is 3. Now keep in mind that you have to subtract the number which is only odd starting from 1. and up to certain point you will get the value as 17, and the odd number is 17, which is equal to 0, and this will be your ninth step. Just you try by your own, and if you find some kind of difficulties you can ask me. So this ninth step you will get 0. So the on the step the step at which you are getting the subtraction between the number and the odd multiple it as 0, then you can say this step is nothing but the square root of that squared number, that is 9. That means 81, the square root of 81 is 9. Okay, in this way you can understand. Now again there is another method which is called as long division method. Long division method. Okay, long division method, and lots of other rules are also there, but we will cover it on the next session. Okay, in the next session we will see all those rules. But before that I want to give you a homework. Let me erase this first, then I will give you a homework. You will tell me that what will be the square root of that number. Okay, so the homework is that you have to find the square root of um you have to find the square root of